Hello diver friends, I'm Orlando the Quant Diver. So today is a really short video about how you can clean up your dive data to get a good sac rate from it. I made another video about this. It goes way deeper into the subject and it also goes into gas planning. Why bother going through our data when we can just get the sac rate from the Shearwater app? It just takes the start and end pressures and it takes that difference, adjusts it for an average depth and divides over the time of the dive. And that gives me a sac rate that includes everything that happened in that dive in one way or another, because the entire gas consumed during the dive is making its way into the reported sac rate. So if I look at the graph, this purple line is the sac rate. I can see that it goes way up here because I'm inflating my BCD, and it goes negative here because I'm ascending. And all of that is warping the data to get a calculation that is not necessarily representative of reality. Let me show you why it's so important that we get a precise sac rate from our data. This is a simulated dive. I dive a rebreather. So in this dive, I'm going down from the surface to 100 feet over 5 minutes. Then I am staying around in the bottom until I become hypercapnic and I need to bail out. At this point, I bail out. I take 5 minutes to get it together, and then I start heading back up to the surface. Okay, this is the simulation. At the 10-minute mark, I start breathing from my bailout. Imagine my bailout is my 3-liter diluent tank. I'll run out of air with it before I even start heading up. Okay? If my bailout were an aluminum 80, then that will take me to the surface just barely. I would end up with about 13% of the tank's fuel capacity. Let's say I dove at still 100. I would end up with 30%. If I had double stills, 65%. Okay, so now I know that when I take my aluminum 80, that's enough to get me to the surface, but it's not enough if I'm doing a deco dive. So this is all dependent on what my sac rate is. So I have to make a little bit of this all depends on what my sac rate is. If I use the Shearwater sac rate, then this is what this would look like. As you can see, again, my 3-liter tank is not gonna take me to the surface, but an aluminum 80 won't do that either, or nor even a steel 100. I would need to dive double steel 100s if I wanted to make it out alive from this dive. So the real issue is not with Shearwater, it's with having a canned sac calculation. Here, if we use this calculation and we just take this number, we end up having to take double steel 100s as our bailout. And I promise you that most people will not do that. And then what we're gonna end up doing is not following our own procedures. And when we stop doing that, that's when things become dangerous. It's not a question about not being too conservative. We're being conservative by using the original calculation and sticking to aluminum 80s, but we're also being realistic and precise and basing ourselves on reality. And so that's why I do my own calculation. So divers, this is very quickly how I clean the data. This is the same dive that we saw in the Shearwater app. The first thing that we need to do is get rid of the effect of our inflator on our air consumption. When we are going down, we are gonna hit that inflator button until we become buoyantly neutral, and that's gonna cost us a lot in our sac stat. So we get rid of that. Just get rid of the first few minutes of a dive. I personally get rid of the first 5 minutes of every dive. It just so happens that in this particular case, that's not enough, and so we need more checks. So other checks that I do are I try to get rid of the inflation effect across the board. I do that by just taking the average depth of my dive and just focusing on the data points that are within a range of that depth. That way, I'm not accounting for inflating my BCD to become buoyantly neutral. So here, you can see what some data points would look like. However, if you look at this part here, this is another issue that you will find. You see this vertical line going all the way down. That's a negative sac rate. We get that because this is an ascent portion of a dive. So in this ascent portion, there is a increase in the transmitter pressure reading because of the gas expanding in our cylinder. That reads as a negative sac rate, and that also has to go. Okay, another thing is that if you notice, there's not a lot of samples on this dive. So what you want to do is get many dives. And what you're seeing here is a distribution. So the 25th percentile, 50th percentile, 75th percentile, the max sac rate, and the minimum sac rate. So I focus on the mean sac rate. And you can see that I have two columns. And that's because for every single dive, I take two values. One is the normal sac rate. So that is just the average sac rate. And then the other is the exerted sac rate. So I take that as the 95th percentile of every dive. Okay, and lastly, if you're paying attention, and I hope you are, I just wanted to show you how I came to these values here. So this sac rate that I'm using here is a heavily penalized sac rate. It's based on what I observe, and then I multiply by 3 to get a value for a scenario where I'm hypercapnic, meaning I'm breathing a lot. The shearwater data gave me a liter equivalent of 28, and I have a liter equivalent of 17. That's what my report gives me. So I just took the ratio of that 28 to my actual sac rate, and I multiplied it by my exerted sac rate. Thanks divers for watching all the way to the end. Like and subscribe if you like this content, leave a comment, all of that helps me a lot. I want to hear from you, I want to know what kind of content you want to see that has to do with quantitative diving, quant diving. Okay, but if you like this particular topic, I have this other video and it goes into more detail. Anyways, I hope to see you in the next one. Bye.